Welcome to the 9th session of ionic equilibria. In this session, we will be continuing with the hydrolysis of salt, which we had started in the ionic equilibria 8th session. Here, we are going to deal with the hydrolysis of strong acids and weak bases, which combine to give a salt, and such salts, since one of that electrolyte is weak, undergoes hydrolysis. So, these are salts of strong acids and weak bases. Let us see what are some of the examples. First one you can take as a strong acid is HCl plus a weak base, that is ammonium hydroxide, which reacts to give ammonium chloride. So, that is one of the example. You can also have another example. You can take HCl itself, or let it be HNO3. When treated with a weak base, copper hydroxide, so you will be needing 2, and here we will be having a byproduct of water, the salt is ammonium chloride. Okay. In this case, when nitric acid reacts with copper hydroxide, you will have copper nitrate as the salt, this is the salt, and of course, you will be having water as byproduct. So, any salt which is formed from a strong acid and a weak base, here copper hydroxide is a weak base, ammonium hydroxide is a weak base, nitric acid is a strong acid, HCl is also a strong acid. So, such type of salts, since one of the electrolyte, that is in this case it is base, it will undergo hydrolysis. Now, let us see how is it being shown. Now, we will take one example and let it be ammonium chloride. Ammonium chloride dissociates into ammonium ions and chloride ions. Chloride ion comes from a strong acid, and therefore, this ion will not undergo any hydrolysis. It can undergo only hydration. When we take the case of ammonium ion, which is a part of a weak base, it undergoes hydrolysis, that is this cation undergoes interaction with water to form ammonium hydroxide releasing H3O plus ions. When H3O plus ions are released into solution, that is you can say when I put ammonium chloride in water, the concentration of H3O plus increases, which means that the solution becomes acidic. Okay. To remember, it is very easy, you just look at the salt from which it has been formed. It is from a strong acid and a weak base, and therefore, the salt on hydrolysis will be acidic in nature. If it is from a weak acid and strong base, as we have seen in the last session, the salt formed will hydrolyze. Since the base is strong, the solution will be alkaline. This is the best way to remember. Okay. So, this becomes an acidic solution. Now, we will find out expression for hydrolysis constant, degree of hydrolysis, and also the pH of the solution. Here, I am going to take a common salt, which we always write it as B plus A minus, that will be ionizing. So, I have written it in the form of ions. It interacts with water to form H3O plus, that is one of the proton is donated to water, it goes H3O plus with A minus. Actually, this is an acid HA, which will be completely ionized, and since we can't write H plus alone, it is written as H3O plus A minus. So, this forms the acid part, and acid being strong, it is completely ionized, we have it in the form of ions. And the base is regenerated. Here base is weak, and therefore, we will take the expression, because therefore, there will not be any ions from that. Now, I am going to remove some of the common ions. See, here I am having A minus ions, and here also I am having A minus ions. So, I am going to exclude that, and the expression takes the form B plus 2 H2O gives H3O plus BOH. Now, we can write a constant KH. KH will be equal to, I am going to consider water to be present in excess, and therefore, KH will be equal to H3O plus into concentration of BOH whole divided by concentration of B plus. Okay. So, this is from this expression we will get KH as this. Now, since the acid is strong and base is weak, I can take the ionization of the weak base BOH will ionize as B plus OH minus. Now, for this I can put the constant dissociation constant for the base Kb is equal to concentration of B plus into concentration of OH minus whole divided by concentration of BOH, that is for Kb. Now, we all know that Kw of water is equal to concentration of H3O plus into concentration of OH minus. Now, what I am going to do is, I am going to divide Kw with Kb. So, next is Kw is divided by Kb, which is equal to Kw is H3O plus into OH minus divided by Kb is this expression. So, in denominator we will have B plus into OH minus, and this denominator goes to the numerator, you will have BOH. Here we have common terms, I will cancel that, that is OH minus in the numerator, OH minus in the denominator. So, these terms are cancelled and the equation takes the form H3O plus into concentration of BOH whole divided by concentration of B plus. Now, just compare this equation with the KH of the solution. See, it is the same as which we have obtained now. What does it mean? Kw by Kb results in the expression of KH. So, I can write an expression for KH as KH is equal to Kw by Kb. So, this is an expression, we have lots of expressions for hydrolysis constant for different salts. When the acid was weak and base was strong, just recall it was KH is equal to Kw by Ka. So, this is the case when acid is weak. Here we have considered the case where acid is strong, but base is weak. So, here we are having a weak base, and therefore, the expression for hydrolysis constant is equal to Kw by Kb. If acid is weak, it will be Kw by Ka. So, just recollect that. Next, what we are going to do is, we are going to derive an expression for degree of hydrolysis. Degree of hydrolysis is a fraction of molecules that has undergone hydrolysis, and it is expressed in the form of X. Okay. Now, again I am going to take the expression, that is B plus, that is the same as we have arrived at here, B plus plus 2 H2O giving H3O plus BOH. So, I will take that expression B plus 2 H2O reversibly gives H3O plus BOH. Now, initial concentration, again we have assumed it as C moles per liter. At initial state you do not have these two formed and therefore, they are 0. At equilibrium, if x is the degree of hydrolysis, then concentration of B plus ion will be C into 1 minus x, because 1 minus x is for 1 mole multiplied by C gives you the concentration for C moles. And since degree of hydrolysis is x, 1 mole can give 1 mole of H3O plus and 1 mole of BOH. X moles are dissociated out of 1 mole and therefore, it becomes for 1 mole it will be x and x, for C moles it is C into x into C into x. Now, the hydrolysis constant K H is equal to concentration of H3O plus into concentration of BOH whole divided by concentration of B plus. Okay. Now, I am going to substitute for that. Here we are having the concentrations H3O plus is Cx, BOH is again Cx whole divided by concentration of B plus is C into 1 minus x. Okay. Cancelling the both C's, you get the expression as C x square whole divided by 1 minus x. Now, again this is actually the degree of hydrolysis without any approximation. Now, I am going for an approximation, since x is very small than 1, x minus 1 can be approximated to 1. So, this becomes 1. So, what will be K H? K H is equal to C x square, or I can put it as x equals, or I put it as x square is equal to K H by C, or x is equal to square root of K H by C. Now, since this is from a weak base, K H is equal to K W by K B. Substituting for K H, the expression takes the form x is equal to square root of, instead of K H I am going to put it as K W by K B. Into C, which is in the denominator. So, this is the expression for degree of hydrolysis in the case of a salt formed from strong acid and a weak base. So, weak base is involved, we have K B in that equation. Now, just recall, for the salt formed from weak acid and strong base, weak acid and strong base, the only difference you can see it is the square root of K W by, instead of K B you will be having K A. Now, one more point, you can note that in both cases, whether it is weak acid or strong base, whatever the cases, or you can have strong acid and weak base, in any case there is a factor C involved in degree of hydrolysis, which means that degree of hydrolysis depends upon the concentration of the solution. Okay. Now, we will go for the expression of pH. Before going to expression of pH, we should note that from this expression the concentration of H3O plus is Cx. So, I can put it as, because we want pH, if concentration of H3O plus is available, you can take pH from that. So, H3O plus concentration is equal to C into X, but X for this is square root of Kw by Kb into C. So, I am going to substitute for that. That is H3O plus concentration is equal to C into, instead of x I am going to put this as Kw by Kb into C. So, this is root C and this is the whole C. So, I can just cancel that, this C and this C, the answer will be root C. So, I can take this C inside the root, but that will be in the numerator. That will be square root of Kw into C whole divided by Kb. So, we got it as such. Now, we have to convert that into pH. So, what I am going to do is taking negative logarithm on both sides, negative log of H3O plus is equal to negative logarithm of, instead of square root I am going to put it as raised to the power half, the C whole divided by Kb whole raised to half, means root. Okay. Now, I am going to expand it, and this side I can make it as pH is equal to minus of half log Kw, again for this minus of half log C. So, numerator is over, it comes minus of minus Kb. So, that will be plus half into log Kb. Okay. Now, minus of log Kw, that is I am going to take the minus sign and log Kw, which can be written as Pkw. Of course, the half is there. Now, again here you can't do anything, it is simply log C. So, that is equal to minus of log C. Now, in this case I can make it as minus of minus, and this minus and log Kb together I can make it as Pkb. So, minus of half log, sorry, no log, I make it as Pkb. Pkb. Okay. Now, Pkw, the value of Pkw is equal to 14. So, that is equal to half into 14 minus, I am going to take the half outside and the minus sign outside. So, that it becomes log, I will just change the direction, because in the last derivation we have put Pkb first. So, I can put it as Pka in the other one. So, it is Pkb in this side plus log C, because the minus sign is taken out. So, minus half log C becomes positive, again minus of Pkb becomes positive. So, 2 into 14 minus half, you have Pkb plus log C. Now, again 2 goes 7 times. So, the expression for pH 7 minus half into Pkb plus log C, and this is the expression for pH. When we have a salt in which the base is weak, and when base is weak we have to consider the acid to be strong, not both are weak. Okay. In that condition pH is equal to 7 minus half into Pkb plus log C. Now, let us conclude. Here we have been discussing the hydrolysis of salts of strong acid and weak base, and we derived an expression for hydrolysis constant K H, which is equal to K W by K B. Degree of hydrolysis X for such a salt is equal to square root of K W by K B into C. Here we can find the concentration term involved, and therefore, concentration term determines the degree of hydrolysis. And finally, the equation for pH we have derived as 7 minus half into log pKb plus log C. Thank you.